Hello, so I have a problem in front of me, which states, given that tan A equals negative 5 over 12, and that angle A is obtuse, they're asked to find the exact value of, and I'm just going to pick one or two examples. Let's say we need to find the exact value of for part A of, let's just say, cos A, and for part B, let's say we need to find the exact value of sec A. Actually, let's say cosec A. Now this is an interesting problem, and I suppose it serves the purpose of emphasizing that I think for trig at this level, which is A level, early undergraduate, I would say, up to early level 4, this tends to prove to be true, this following statement, it's really important to have a good grasp of all the tools and concepts available. And that's probably also true for calculus, whereas I find in other cases we can deal in fragments a little bit more, isolate different formula a little bit more, and just kind of what they call plug and chug. But for trig, I think it's really important to have a good sense, first principles of sort of the deeper relation between all of our identities. You know, we have our reciprocal quotient identities, our Pythagorean identities, law of sine, cosines, double angles, half angles, angle sum and difference, and all of these things. And so this example might serve the purpose of emphasizing that point. So we need to find the exact value of cos A. So I'll start my working here on the right. We know that tan A is negative 5 over 12. And so in defining the exact value of cos A, there are two methods that immediately stand out to me that I'm familiar with, at least. And the first is to find an identity that associates tan, which we have here, the value of here, and cos. So one might think, well, Pythagorean identity, sine squared theta plus cos squared theta equals 1, but what jumps out here is the identity tan squared theta, or A, angle A in this case, plus 1, which equals sec squared A. And sec, of course, is 1 over cos, and quickly a good memorization technique to remember that and to memorize is that if you, at least when it comes to how we write it in the UK, is every third letter, right? So sec, every third letter, well, the third letter is C, so it's 1 over cos. If you had, for example, cot, well, the third letter is T, so it's 1 over T, or 1 over 10, obviously, right? And if you had cosec, right? Cosec, it's the third letter is S, which means it's 1 over sine. So that's just a useful thing that I find, a good memorization technique, at least when I first learned this. But in any case, so this is the identity that I immediately think of, because we can really write this as tan squared A. Of course, we know the value for 10, plus 1 equals, and we've already said that this is 1 over cos squared A. So now we've got cos and we've got tan together. We have some relation or association here. We can now just substitute our value for tan, and we're going to square that. So tan A equals negative 5 over 12. So negative 5 over 12, we're going to square that, and that of course is plus 1. And then we still have that set to be equal to 1 over cos squared A. So what is this squared? That's 25 over 144. 25 over 144. If you add 1, it's 25 plus 144, which is 169 over 144. So we have 169 over 144 on the left, and we've got 1 over cos squared A on the right. And then we just want to flip everything, don't we? Because we want to solve for cos A. So if we flip everything around, what we end up with here is, and this is just basic algebra, of course, we get cos squared A equals 144 over 169. Take the square root of both sides. We get cos A equals plus minus, well, we know that the square root of 144 is 12, and the square root of 169 is 13. So we get plus minus 13. And now we need to ask ourselves, which one is it? Is it positive 12 over 13 or negative 12 by 13? And the best way to do that is one could probably do it in their head very quickly, but for the sake of this video, let's just draw it out and think of the unit circle, or we can think of the of a cos graph of cos x here. We know it looks something like this. This is a very quick sketch, right? And that's of course 90 degrees. That's 180, 270, and so on. And we're told here that angle A is obtuse. Obtuse is between 90 and 180. So that's going to tell us immediately that cos is going to be negative, right? Because 90 and 180 in this part, the cos x, we see it's negative. The value of cos is negative here. And so we're going to take the negative value that we ended up with, so we get cos A equals negative 12 over 13. And that is our value for cos here. Now the second method actually is a little bit more simple maybe. If one has memorized exact values in relation to the unit circle, and has a good sense or knowledge of Pythagorean triplets, you could immediately think, okay, well, we're told that tan A is 5 over 12. What is tan? Tan is opposite over adjacent. So you could say, okay, well, let's just draw a unit circle. Let's draw a right triangle here, something like this. That's 90 degrees, a 90-degree angle, of course. And this is, we'll just call this angle theta or angle A. And so tan is negative 5 over 12. Tan is opposite over adjacent, so we're going to say, well, this is 5, the adjacent is going to be 12. And you could say, okay, so we've got a 5 and a 12 here. One would say, oh, well, this is a 5, 12, 13 triangle, right? It's a Pythagorean triplet. And you could find that out if you wanted to. You could denote that as, I don't know, x. You could write x squared equals 5 squared plus 12 squared. That's of course 25. That's of course 144, and that together is 169. So if I just do a bigger arrow here to cancel all that out, we know this is 169. You take the square root, that's 13, right? So it's a 5, 12, 13, as I said. So Pythagorean triplets, and so we write that here. And you'll say, okay, so we've already found the value of this triangle. It's a 5, 12, 13. In terms of the actual angle, you could say, well, we know that we need to find cos of A. Well, what is cos A? Well, cos is adjacent over the hypotenuse, so you would say, okay, well, cos A therefore is the adjacent, which is 12, over the hypotenuse, which is 13. And then you're going to say, well, we know we're also that our angle is obtuse, henceforth, well, hence why I drew it in the second quadrant. We know cos is negative, therefore cos is negative 12 over 13. So that's the second method. I prefer the first, but I always tend to default to algebra. That's just my own personal preference. I don't have any real explanation as to why that is the case. It just tends to how I've always been. But one could easily just work it out quite quickly this way, as you can see. And so what's interesting too is we've ended up with the same answer with two very different methods, right? Two very different methods. We get the same answer, and that's just one of the wonderful things about trig. Is what do we say? Maybe the fundamental connection or relation between all the concepts and identities and things as we learn in relation to the graph, as we see here. What we learn about in terms of the unit circle and special right triangles, the Pythagorean triplets. It's really quite nice, and so to sort of emphasize my point, if you have a good understanding, a good base first principle understanding of all your key sort of core concepts and all of kind of key or core tools that we're given, then you can easily think through any trig problems you're given, just very logically, even like such in the first example we said, okay, well, let's just think of an identity, right? Or in the second, it's a good bit of logic here to just think, well, we know if tan is opposite over adjacent, we have our values here, and so on. We finally have a Pythagorean triplet, which you would need to remember. You need to memorize this is a special right triangle. But in any case, I've probably rambled on enough about all of that. So let's just work on part B. We need to find cosec A. I'll just work through both methods again very quickly, just to sort of emphasize the point. It's nice to think about both methods. I'd like to do that at least. And so cosec A we know is 1 over sine A. And of course we already know that tan is this value. So let's think of an identity. What links tan and cosec? Well, what stands out would be cot squared theta, or in this case angle A. So cot squared A plus 1 equals cosec squared A. I keep wanting to write theta. Force of habit, I suppose. And right, so we know what cot is. Let's how should we write this? Well, we need to solve for cosec squared or cosec A. So let's rewrite cot. So we know cot is 1 over tan squared A, and oops, that should be plus 1. Got ahead of myself. Plus 1 equals cosec squared A. And now we can just plug in our value for tan squared A, and we need to square everything, of course. So we know tan A is negative 5 over 12. We're going to square that. Negative 5 over 12 squared plus 1 equals cosec squared. Oops, not cos squared, it's cosec squared A. What we could do here is, and we're going to kind of flip everything as well. So we square it. We know that this is, let's just write it this way. This is 25 over 144. And then we're going to flip everything. So it's going to be 144 over 25. So let's write it like this, 144 over 25. Now we're going to add 1. So that's going to be, it's going to be 169 over 25. So I'm just going to cross this whole thing out like this, 169 over 25. So which equals cosec squared A. Therefore, the algebra 1 could probably already see where this is going. It's very simple. Take the square root of both sides. You get 13 over 5. 13 over 5. And that's actually plus minus 13 over 5. Right, and that's our answer. And now for method 2, we can even just confirm that's the right answer if we want to. Again, we just think, well, we know that the value for tan, we know that angle A is obtuse, or actually, yeah, that's right, cosec. So let's actually take a step back for a moment, because what is it going to be, positive or negative? So we can think of the sine. Let's think of the sine graph like this. Goes like this and like this, something like that. Just a quick sketch. We know that's 90 degrees, and of course, when it's obtuse, it's between 90 and 180. So it's like something like that. This value here, which is positive. Which also for cosec, that would also prove to be the case. And so we know that this is going to be positive. So we'll just write it this way, 13 over 5. And so now let's, for part B, do the second method, and let's just plug in. Again, we'll just use the unit circle. And we know it's going to be positive, but in any case, if you didn't know that, you could just draw a right triangle and figure it out afterward. And so tangent is the opposite over the adjacent, so it's going to be 5 over 12. And we have cosec of A. And cosec we know is 1 over sine. What is our value of sine? Well, sine is opposite over the hypotenuse. We could figure this out, that this is going to be a 13, right? So, as we've already noted, and so you could write that this is cosec is 1 over sine of 5 over 13, or you could write that it equals cosec of 13 over 5, which is exactly what we found, and that would be our answer. Right, and yeah, that concludes this video.